Today we are going to learn about section 3.4, which is the distance formula. So to start this off, there's a bell ringer at the top of the notes today. So let's go ahead and work through that before we get into the notes. So let's just go ahead and simplify this expression. We need to work on our order of operations here. So the first thing we do is parentheses. So 5 minus 2 is 3. And negative 3 plus 7 is 4. So I now have the square root of 3 squared plus 4 squared. We can look at that big square root sign as like a set of parentheses. So we need to do everything inside of that before we take the square root. Now I need to do my exponents. So 3 squared is 9, 4 squared is 16. So I now have the square root of 9 plus 16. I'm down to addition. So 9 plus 16 is 25. So this is the square root of 25. And now I can take the square root. I couldn't take it until I got just one number under that square root sign. And now I know the square root of 25 is 5. So that's my solution here. All right, let's go ahead and get started with these notes. So today you're going to find the distance between any 2 points on the coordinate plane. So in order to do this, we're going to reason abstractly and quantitatively when we're finding the formula for the distance between 2 points and when we're using that formula to find the distance between those 2 points. So to get started, we're going to go ahead and create a triangle. So we're going to plot these 3 points on this coordinate plane right over here to the left. And then we're going to connect the points to create a triangle. So point A is the point 1, 1, B is the point 1, 7, and C is the point 6, 1. So those are now plotted, and we can connect our 3 sides. So let's go ahead and find the distance between all 3 of these points. So starting with the distance from point A to point C, you can count how many units we go to get from A to C. So if you count it, we go 5 units. So that distance is 5. Similar with A and B, except instead of moving from left to right, we're going to be moving up. So if you count how many points we go, the distance from A to B is 6 units. Now let's figure out the distance from B to C. This isn't straight across or straight up and down, so we cannot just count the points to find the distance. But if you notice, this is a right triangle. So we have a special tool that we've been working on that can find us the distance from B to C, and that's the great Pythagorean theorem. So if I go ahead and plug in my numbers for A and B, which would be the 2 legs of this triangle, I get 6 squared plus 5 squared equals C squared. And now I can go ahead and solve this for C. So I'm going to rewrite this as 36 plus 25 equals C squared. That simplifies to 61 equals C squared. And then I can take the square root of both sides, and I get C is equal to the square root of 61. So that's the distance from B to C. So how can we find the distance between points B and C without having to use or without even having to know point A? So we're not always going to have a perfect right triangle to find a distance. And so if I'm given any 2 points, I want to be able to just find the distance between those 2 points. I don't want to have to draw out this perfect triangle. Well, let's think about this. We need to find the distance between any 2 points that do not create a line parallel to an axis. So between A and C and A and B, those lines were parallel to the x-axis and the y-axis, so we could just count the points. But in most cases, that's not going to happen. So we want to be able to find it. So we know we've used the Pythagorean theorem to find the distance from B to C. So our Pythagorean theorem is right here. A squared plus B squared equals C squared. So now let's write this in terms of the sides of this particular triangle. So A was the distance from A to C, and B was the distance from A to B, and then C was the distance from B to C. So now instead of writing the sides, AC and AB, can we write this in terms of X and Y? Well, if we think about it, the distance from A to C, we counted the X coordinates. We counted how many X coordinates we moved to get from A to C. And it ended up being 5. Another way to look at this, instead of counting it, is C is at 6 and A is at 1. So if we subtracted 1 from 6, so if we did 6 minus 1, that would have given us 5, which was the distance. Same thing with A to B. We counted the Y coordinates, but if we would have taken where B is, which is 7, minus where A is, which is 1, 7 minus 1 is 6, and that was the distance from A to B. So, another way of writing this equation is to write the change in x's, so x2 minus x1. Those fancy small numbers there are called subscripts, and they're just a different way to show x's that are still different. So x2 would be the 6, so that would be the x that C is on, and x1 would be 1, that would be where A is at. So if you take x2 minus x1, 6 minus 1 is 5. Same thing with the y2 and y1. If you took the y2, that would be B, minus the y1, which is A, 7 minus 1 is 6. So that works out. So now let's go ahead and solve this for BC. All we need to do is get rid of that square to get BC by itself. So let's square root both sides of this equation. The right side of the equation can simplify to BC, but the left side of the equation doesn't simplify. So let's just leave it as the square root of the quantity x sub 2 minus x sub 1 squared plus the quantity y sub 2 minus y sub 1 squared, and that's equal to BC. Alright, so what does this all mean? Well, that formula right there gives us BC. So it gives us the distance from B to C. So that formula, the square root of x2 minus x1 squared plus y2 minus y1 squared, is our distance formula. So let's try this out. Let's see if we can get it to work out. Let's go ahead and find the distance between the points 1, 3 and 2, 5. Well, before we do anything with our formula, let's make sure we have our points labeled correctly. 1 would be the x1 because it's the first x. 3 would be y1 because it's the first y. 2 is x2 because it's the second x. And 5 is y2 because it's the second y. So now that they're labeled, we can go ahead and plug them into our formula. Go ahead and write our formula out first. That way we make sure we don't plug numbers into the wrong spots. So now we can go ahead and substitute our numbers in for our variables. And from here, this is just like that bell ringer. where we used order of operations to simplify this down. So 2 minus 1 is 1, 5 minus 3 is 2, so I have the square root of 1 squared plus 2 squared. Now I'm going to do my exponents, so 1 squared is 1, 2 squared is 2, so I have the square root of 1 plus 4. And now I can do my addition, so this equals the square root of 5. And then this is all I can do. I don't know the square root of 5, so I can't simplify it any further than this. Let's try another one. Let's find the distance between the points -2, 6 and 10, -8. The first thing we need to do is label our points. So -2 would be x sub 1 because it's the first x. 6 is y sub 1 because it's the first y. 10 is x sub 2 because it's the second x. -8 is y sub 2 because it's the second y. I'm going to go ahead and write out my equation before I substitute any numbers into it. And now I'll substitute them in. Make sure you pay attention to your signs because we're doing subtraction within the parentheses and then we're adding the separate parentheses. So I have 10 minus a -2 squared plus -8 minus 6 squared. So I'm going to go ahead and rewrite this by adding the inverse. So 10 plus a +2 and -8 plus a -6. 10 plus 2 is 12. -8 plus -6 is -14. So I have the square root of 12 squared plus -14 squared. 12 squared is 144 and -14 quantity squared, so the negative is included, is a +196. I'm going to add those up to get square root of 340, and this one does simplify. It multiplies out to 4 and 85, so it simplifies to 2 times the square root of 85. Let's try one more. Let's do the points 0, 5 and 7, 0. So first of all, let's label our points, x1, y1, x2, y2. Write out our formula. And now we can substitute our numbers in for our variables. So I have the square root of 7 minus 0 squared plus 0 minus 5 squared. 7 minus 0 is 7. 0 minus 5 is -5. I'm going to square both of those to get square root of 49 plus 25. Add those together to get square root of 74. And that number does not simplify. There's not a perfect square. That's a factor of 74. So I'm done with that problem. All right, you're ready to work on your homework. If you have any other questions after watching this whole video, feel free to send me a message on Canvas, come in during advisor, or come in the morning. I'm more than willing to help you on this homework. Make sure you have it done tomorrow. It's due in class on Tuesday.